how is climate change or greenhouse gases linked to climate change? Here's a figure. It really shows what it's all about. Here's the sun. The sun, shines on the Earth, and the Earth, as you know, has an atmosphere. That atmosphere acts like a warm blanket around the Earth. When we talk about greenhouse gases, when we talk about global warming, we're talking about the sun shining on the Earth and warming up our atmosphere. The warming of that atmosphere is mostly done by greenhouse gases. Greenhouse gases, there are a range of them: carbon dioxide, methane, nitrous oxide, F gases, chlorofluorocarbons for those people my age and older maybe. Water is also a greenhouse gas. These are the gases that absorb the energy from the sun and warm up our planet. There is also greenhouse warming coming from the light hitting the Earth, bouncing back into space. Kind of what we see there. That is what we're talking about. Without greenhouse gases, without atmosphere, the Earth would be particularly cold. When I'm talking particularly cold, I mean uninhabitable for life, minus 30, minus 40 degrees. Without those greenhouse gases, we need them here to make life tolerable for us. But we don't need too many of them. So, but people think greenhouse gases, greenhouse effect, maybe it's a new thing. Why are scientists talking about it now? I just have this slide to show you a little bit. Greenhouse effect has been around for a long time. It's been understood for a long time. On the left here, I have the history of greenhouse gas. On the right here, I've gone the history of the East Coast. It's worked really well in Queenstown because I had some good things. I've tried my best for the East Coast. Tell me how I get on. So in 1820, Georges Bay was first used by whalers. St Helens was named in 1835. Back in around that time, 1824, French scientist Joseph Fourier was the first person to say that carbon dioxide and other similar gases, nitrous oxide, methane, water vapour, trap heat in the atmosphere. He was the first one to say that almost 200 years ago. He didn't really understand how how much things, but he put that forward, and from then on we've understood this idea of greenhouse gases. About 70 years later, tin was discovered in Derby. The railway from Launceston came through to the East Coast, 1870s, 1880s. Around that time, 15, 20 years later, a Swedish fellow named Svante Arrhenius, love the name, he was the first person to estimate the impact the changing carbon dioxide levels would have on the Earth's temperature. So he tried to quantify the impact of greenhouse gases on the Earth. He actually came up with a calculation done by hand on his paper and pen, of course, that if we doubled the level of carbon dioxide, we'd increase the Earth's temperature by 6 degrees. It's not bad for almost 120 years ago now. He wasn't quite right. We'll see that in a minute. Arrhenius, though, he thought we had very little capacity to impact the level of greenhouse gases. He thought it would take about 3,000 years before man would start to have society would have an impact on the level of greenhouse gases. He clearly didn't fully appreciate our ability to industrialise, start burning coal and drive cars. Last one I've got here, the mid-70s, the Triabunna wood chip mill began operation. It's a long time ago now. It stopped, of course. 1979, almost exactly 40 years ago. It was 40 years last week. It's a report named the Charney Report, estimated that a doubling of carbon dioxide would lead to a temperature rise of 3 degrees. That was really the start of modern climate science. Doubling of carbon dioxide in the atmosphere lead to a rise of 3 degrees global warming. So these ideas of global warming, of carbon dioxide having an impact of greenhouse effect, we've understood them as scientists for a long time. So, carbon dioxide and temperature, it is a thing. Here I've got a couple of figures. I love figures. I know that everyone does, so work with me through these. And Peter and others will just go, Stuart. Here I've got a figure. This is the concentration of carbon dioxide from 1880 through about today, 2020, 2018. And you can see we've gone from about 290 parts per million, 290 parts per million. It's not a lot as a concentration. But in that 130 years, 140 years, we've risen up to about 410. It's now 414 parts per million. It's about a 50% increase in the level of carbon dioxide. Over the same time, this is a plot of the observed global temperature. And you can see it kind of also goes up. There's a relationship there. There's at least a correlation there. I would say there's a causation between the two of them, but you know, we can argue that. And in fact, it's not just over the last 150 years we can see that. This is a graph done by looking at ice cores and a few other fancy things of carbon dioxide, temperature in red, carbon dioxide levels in the blue for the last 800,000 years. And you can see that when one goes up, the other one goes up. When one goes down, the other one goes down. This relationship between the concentration of carbon dioxide and the temperature of the Earth are closely related. They have been for hundreds of thousands of years, at least. One of the things, as Greta said, yes, it's been going on, but the amount of carbon dioxide we are releasing now is an unprecedented rate, at least the fastest we have done for the last 66 million years. 66 million years, that was when the dinosaurs were wiped out, for those dinosaur people. This guy here is a dinosaur person. So you might ask, and it's the last question I've got, how does carbon dioxide make a difference? We talk about 280 parts per million. It's such a small amount. Maybe it's 414 now. Well, I'll just finish with these for you then. So he wasn't driving, he wasn't drunk. He just had a tiny amount of blood in his alcohol. It's about 500 parts per million. 0.05 is 500 parts per million. You tell me, does that 500 parts per million make a difference to your driving? It does for me. I'm not a great driver. Same, ibuprofen, Nurofen, painkillers. Does it do anything? We only need 2.5 parts per million of ibuprofen in our system to start making a difference, to ease our headache. It's a really small amount. These trace amounts can really make a difference. The last one there, your child, you can drink that water. It's only a tiny amount of arsenic, 0.01 parts per million. That's the safe level of arsenic in drinking water. So you can see these trace amounts, even though it's small, it really can have a big difference in our atmosphere or in our safe drinking water.